Euclidean distance is one of the popular property, while developing the algorithm, to create clusters in the given data set. Before we jump to Euclidean distance, it is important to know about linear distance, Cartesian distance, and spatial distance. Linear distance is the simplest one. Say, point A is at mark 2 on a linear scale and point B is on mark 6 on the same linear scale. Then, linear distance between points A and B is simply the difference of the 2 points' location. And is given here. Let's move on to Cartesian distance. Cartesian plane is a xy plane, or two-dimensional plane, that have two axes x and y, crossing each other at right angle. The crossing point is called as origin. It is shown in the figure here. The points in a Cartesian plane are represented by their coordinates as x and y, taking their respective values. Points A and B, here are at coordinates, 1, 4, and 4, 2 respectively. Now, the Cartesian distance between points A and B, can be formalized by using the Pythagorean theorem. The formula for Cartesian distance is self-explanatory here. Let's move on to spatial distance. Spatial plane is a three-dimensional plane. It has three axes, namely, x, y and z axis. All the three axes cross each other at right angle. The crossing point is again the origin, as in case of Cartesian plane. A point in spatial plane is represented by three spatial coordinates, as x, y, and z. Points A and B are taken here, as an example. It can be observed here, that, the 2 points are in space now. The distance between two spatial points is called as spatial distance. The Cartesian distance formula is extended here to give the spatial distance. From here, we can define Euclidean distance now. Consider, point A at position 3, 5, and 5 at time t equal to 3 seconds. And moves down to position B with 8, 2, and 10 at time t equal to 5 seconds. Therefore, adding the time dimension into the spatial coordinates, the particle's position, now becomes vector. And the distance between two vectors is called as the Euclidean distance. The formula for Euclidean distance is now the general form of Cartesian, or spatial distance. Computation of Euclidean distance can be understood from the example here. The two vectors should be of same length for computation of Euclidean distance. Moreover, Euclidean distance is the straightest and shortest distance between any two given vectors.